Kia ora koutou. This is a pretty short, easy question from the November 2015 Pure paper, Pure 3. It's on exponentials and differentiation. And it's one that could be a merit question in level 3 calc, definitely not an excellence question. We're given a curve with this equation, and we're told it's got one stationary point, and we just have to find the exact values of the coordinates of this point. This question was pretty well done in the test on Monday, but some of you tried to do it as a product instead of a quotient. So you started by rewriting like this, and I think that actually made things a bit worse, and it made it a little bit harder to find the stationary point, right? You'll get there, but it's not that efficient. So sometimes it's just worth getting on with it and doing the quotient rule. So I'm going to start by just writing it out. Hopefully my pen is still working. No, my pen's just stopped working. Ooh, that's a big pain. Oh no, there we go. Okay. Let's try again. So we've got this, and we're just going to get on with doing the quotient rule. So I'm not going to write that all out. If you need to write that all out, probably need to go back to the Delta book and do a whole lot of practice. Start by squaring the denominator, copy that up to the numerator, and now multiply by the derivative of this, which is 2e to the 2x. And now we subtract e to the 2x times the derivative of this, which is 3e to the 3x. Okay, now let's just expand and see what we get. So don't expand the denominator. What have I got? 8e to the 2x plus 2e to the 5x minus 3e to the 5x. And I want that to equal 0 for a stationary point. Right, really important that you write that step down. Now, we can't have the denominator being 0, so all I have to do is to work with this being 0. 8e to the 2x minus e to the 5x is equal to 0. Factorising out e to the 2x, I get this. And we know that e to the 2x is not equal to 0, so e to the 3x has got to equal 8. Now I'm asked for exact values. I'm going to take logs of both sides. So 3x is equal to the natural log of 8. So x is equal to 1/3 times the log of 8. Now lots of you left it like that. That's fine, but it's actually kind of ugly because 8 is 2 to the power of 3. So, using my level 2 log rules, x is simply equal to the natural log of 2, right? Because what I'm doing here is I've got 2 to the power of 3, all to the power of 1/3. Now, you totally don't need to write both of those steps out, but I would probably, if I'm doing it this way, I would probably write this step out, and then I would go to x is equal to the natural log of 2. Okay, so that's not finished though. That's 5 marks out of 6, but we were asked for the exact values of the coordinates of this point. So we now need to chuck that back in and get my y value. Right, let's take a look. Y is equal to, what was y equal to? E to the 2x over 4 plus e to the 3x. Right, we know from up here that 3x is equal to the natural log of 8. So e to the 2x is going to be equal to e to the power of 2 log 2 over 4 plus e to the power of the natural log of 8. And e to the power of 2 log 2 is equal to e to the power of the log of 2 squared over 4 plus 8. This exponential undoes the natural log, so we've got 4 over 12, which is equal to 1/3. So the final answer for this question is the stationary point is at natural log of 2 and 1/3. Okay, thanks for watching. I'll do the other questions shortly.